they will exist in the form of liquids, and if more than 10 or more than 15, they will exist in the form of solids, because if we increase the chain length, they will establish more forces of attraction. As a result, their state will change from gas to liquid, liquid to solid, right? So alkanes, alkenes and alkynes, they show the same type of physical properties. What about their reactions, their chemical properties? Alkynes have triple bond in them, so most of the time they will give you addition reaction. So every time if we add something into alkene, it will get added here by the breakage of triple bond, right? So first reaction is we are going to add halogens. So how we can just add halogens? Just like that, in case of alkene, we use Cl2 in the presence of CCl4. Again, you have to use CCl4 as a solvent. This is a solvent. And Cl2, we are going to add Cl2 here, right? So every time you have to break two bonds. Here we have two double bonds. So we have to perform this reaction in two steps. In first step, two halogens, chlorine. Here we have used chlorine as a halogen, right, for halogenation purpose. So first triple bond will get broken down by these chlorine, and they're going to add across that triple bond. So every single thing is just constant, C, and but we have just broken down one triple bond from here. So again you can see we have unsaturation, and unsaturation helps us in addition reaction. So again you have to add Cl2, and we have just got here again Cl on the adjacent carbon atom by the breakage of this double bond. So what we have done, we have reacted your triply bonded reactant, that is alkyne, with Cl2 in the presence of CCl4, and we have added 2 chlorine on the adjacent carbon atom by the breakage of one double bond, and now we have added the second Cl2 molecule by the breakage of the second bond, and we have added 4 chlorine in your reactant. This is a 2 carbon chain, so tetrachloroethane, right? So we have added 4 chlorine atoms. So your alkynes can give you addition reaction, maybe with halogens in the presence of CCl4. You have to do reaction in two steps. In first step, they will get converted into alkene and then alkane. Is that clear? Mean they will give you the final product alkyl halide. Okay, what about the second step? We can oxidize your alkynes, right? We did for alkane, alkenes and alkynes. They will get oxidized into alcohols and then aldehyde and ketones and then acid. This is a basic criteria. We have learned about the oxidation of your alkene that is mentioned in your book, but they just oxidize up to alcohol. But in case of alkyne, they will form alcohol, then aldehyde and ketone, and then acid. That's what we are going to learn in the next slide. So this is your simplest alkyne, that is acetylene. The other name of ethyne is acetylene. It is going to oxidize in the presence of K-amino4, potassium permanganate, and we know that K-amino4 reacts in the presence of water, and we have to add OH molecule across the triple bond. So we have to add OH group. If we break one double bond, it will give you OH and OH. If we break the second double bond, it will again add OH and OH. So overall we will get 2 and 2, 4 OH groups, because we have broken down 2 double bonds. So 2 OH add for 1 and 2 for second, so overall 4. So this is an alcohol, tetrahydroxyethane, or you can say ethyl tetrahydroxide, or you can name it as ethyl 1122 tetraol, right? So all you need to do is remove this OH and H from this one hydrogen and this OH and OH from this one hydrogen. As a result, you will get aldehyde, C double bond OH. On the one side of C double bond O, you have hydrogen, on the other side you have C. If we have one hydrogen on one side of C double bond O, we just call it as aldehyde. So you just get aldehyde. So first product of oxidation of acetylene is alcohol. Alcohols are further oxidized into aldehyde. Aldehyde is further oxidized into acid. Can you see? C double bond O is attached with OH. That is an indication for the presence of what? Acidic functionality. And here C double bond OH, this is an acidic, this is an aldehydic functionality. This is an acid that is called oxalic acid. So what is the chain products? We get a chain of products in oxidation reaction of acetylene. First alcohol, then aldehyde or ketone, depending on the type of the alkyne, and then your acids. But keep one thing in your mind, KMNO4 is a strong oxidizing agent. We have to choose different methodologies if we want to get final product as alcohol or aldehyde or acid. If it becomes very difficult to control the reaction on this stage. So overall the summary is we can convert your alkenes into alkanes by addition reaction. We can convert your alkynes into alkenes by addition reaction, mean halogenation, and then further you can add H2 and you will get your alkanes. Alkanes can be synthesized by alkenes, hydrogenation of alkanes, hydrogenation of alkynes. So if we reverse the reaction, this will be called as a reaction of alkenes and reactions of alkynes. Clear? So all you need to do is just remember one thing, that the halogenation of alkene results in the formation of product alkyl halide. But if we remove hydrogen and halogen from the adjacent carbon atom, you will get a product alkynes. Okay, and if we use alkyl halide as a reactant, you can remove hydrogen and halogen from the adjacent carbon atom and your product will be alkenes. So if we oxidize alkene and alkynes in the presence of KMNO4, you may get aldehyde or ketone or acid. That depends on the condition that we use during a chemical reaction. That's all for now. Have a good day. Allah Hafiz.